All right, we're going to start today looking at y equals cosine x very close to x equals pi over 6. I'm going to move this paper here because I started to write something. Here's the cosine curve. Ooh, let me see if I can get you to see this. There we go. At from negative 2 pi to 2 pi, negative 4 to 4. And we want to look very close to pi over 6, so I'm going to do a value at pi over 6. And it's right there. And I want to zoom in a little bit closer. So one of the things we can do is something called a zoom box. And see the cursor's there. That's at pi over 6. So I'm going to arrow over a little bit to the left and a little bit up. Hit enter, come down and over to the right. And I've created a box around that spot, pi over 6. Hit enter again, and the calculator will redraw the cosine curve in that window that you determined. There it is. Let's find where pi over 6 is again. Right here. Let's draw another box. Perfect. And where's pi over 6? Right there. All right. I think what you can see what's happening now as we zoom in closer and closer and closer along the cosine curve, closer to x equals pi over 6. That graph looks like a line. And I want you to write the equation of that line, which is the tangent line. So let's set up like we always do. Y minus something equals slope times x minus something. Pi over 6, that's what we were getting close to. That's right here. Right here, that's the function evaluated at pi over 6, which would be cosine of pi over 6, which is, yes, square root 3 over 2. Right here is f prime at pi over 6. Well, if f of x is cosine x, then f prime of x is negative sine x, and f prime at pi over 6 is negative sine pi over 6. So negative a half. There's the slope. Okay. Now I want you to take this line and I want you to convert to slope-intercept form. So that's y equals mx plus b. All right, so first off, let's take this negative a half and we'll distribute through. So we have y minus square root 3 over 2 equals negative a half x plus pi over 12. Then solve for y and add that square root 3 over 2 over to the other side. And we got y is negative a half x plus pi over 12 plus square root 3 over 2. All right, now once you put that tangent line, if you will, into slope-intercept form, we'll call it a linearization. So let's call it L of x equals negative 1/2 x plus pi over 12 plus square root 3 over 2. That line is very close to y equals cosine x at pi over 6. All right, now what I would like you to do is to use that line and estimate cosine of 0.6. Okay, y 0.6 because 0.6 is very, very close to pi over 6. 0.6 is close to 0.523. That's the decimal approximation for pi over 6. So I'm going close. So here's what we want to do. Let's use the estimate from the linearization. That linearization is the tangent line. So let's evaluate this line at 0.6. And we'll have -1/2 times 0.6 plus pi divided by 12 plus square root 3 over 2. And you can believe me on this. The decimal for approximation for this is 0.8278247,916. All right, now find the actual value. The actual value is going to be the function cosine at 0.6. And that decimal approximation is 0.8253356,149. All right, these two are very close to each other. All right. In a nutshell, coming out of all of this work today says, for values of x close to the point of tangency, the tangent line very closely approximates the function values. Phew. For values of x close to the point of tangency, so like this, 0.6 was close to pi over 6, point of tangency, then the values off of the tangent line are very close to the actual values on the function. The farther that a value of x gets away from the point of tangency, the farther that estimate is away from the actual value.